In the last class, we were looking at the Z transform, finding the Z transforms by referring to the standard sequences, transforms of the standard sequences. I mean, we were looking at this. What if there is 2 power n u of n? To which standard transform this belongs to? this looks like a power n u of n. So this is something that we have to solve by looking at this particular transform, standard transform. And similarly here, in place of 2, we have half, that's it. So it's half power n u of n. So both these signals are of the form a power n u of n, where here a is 2, here a is half. So in this equation, in place of a, if it is this, the transform of this, you'll bring 2. In this case, in place of a, you will bring half. And this 3 is a scalar. It has got nothing to do when the transforms are applied. It is kept outside. So we have seen such transforms. Okay. So after this, what we are seeing is, we have seen all this. Yeah. What we had to see today was using the properties of Z transform, find the Z transforms of the following sequences. You should understand by what method we are finding the Z transforms. Okay. Earlier, when we started the class, we found the Z transforms by using the equation. Right. Now, we are finding the Z transforms using the properties. And before this, we found the Z transform by referring to the transforms of the standard sequences. We knew what is the Z transform of u of n. We knew what is the Z transform of minus u of minus n minus 1. We knew the Z transform of a power n u of n. Okay, referring to these standard transforms of unit step function, impulse function, then positive time exponential, negative time exponential. So knowing the transforms of all this, we solve the problem. Okay, today we shall solve the problems by using the properties. Okay, in between, before we started with solving the finding the Z transform, we saw some of the properties like linearity, time reversal, multiplication by an exponential. Okay, differentiation in Z domain. So we saw some properties like that. Okay, today we shall see how to solve the problems using those properties. Everybody get that point? So let's see the problems one by one. And these problems can be solved by using the equation also. Okay, by using the equation also we can solve, but that takes a lot of time. So what we do here is we directly know what is the property to which what property needs to be used for a particular problem. If you're able to make out that, you're through. Okay, the results can be easily obtained. Fine. So I'll tell you how to do that now, one by one. Now this is the problem. We have to find the Z transform of this using the properties of Z transform. Now, which property of Z transform would be suitable for this particular signal is what the question. I repeat, which property of Z transform can be used for this particular function? It is u of n plus 2. Okay, Z transform of the shifted signal, time shift. If the signal is shifted in time, so what would the Z transform of that signal looks like? Understand that? So that is what we're going to see now. Fine. Okay. My request again, those who are logging in, log in with your videos off, please. Okay. Please maintain that, everybody. Yeah. Now, this is the property we're using. Using the time shift property. I inform everybody to focus on this because this is very simple stuff. But if you don't understand the representation, you may end up in confusion. Okay, very simple stuff. You have to just understand the representation of that, how to represent it through properties. So we are using time shift properties. What is understandable now? By how to make out which property needs to be used, seeing the given signal. The given signal is u of n plus 2. The given signal is not u of n, it's u of n plus 2. Understand? So which is the basic signal here? Basic signal is u of n. U of n is time shifted. Okay, so basic signal is u of n. That u of n is time shifted. That's why you're using time shift property. How does the time shift property looks like? Here, time shift property looks like this. What is it telling? If you have a signal like x of n minus n naught, it is plus 2 here, it is minus n naught here. That's it. It is left shifted signal. This is right shifted signal. In right shift, you have minus n naught. Understand? So here you will have z to the power n naught, z to the power minus n naught. If you have minus n naught, okay, and if you have plus n naught here, it would be z to the power plus n naught. Remember this. This we have proved also. Okay, we have proved this. Okay, whatever proof we have done for the property, the same properties are being made use to find out the z transforms. So our job is to remember the properties. Okay, so what is that we need to remember here? If a signal is time shifted, then the z transform, you see, z transform of this time shifted signal looks like z to the power of minus n naught. Why minus n naught here? Because the shift is by minus n naught. Understand? Into x of, what is this x of z here? X of z is the z transform of x of n. It's not z transform of x of n minus n naught. Together it is z transform of x of n minus n naught. Okay, and x of z is the z transform of x of n. Everybody get that point? Okay, x of z here is the z transform of x of n, whichever is the signal. X of n is being shifted, so this is z transform of x of n. So what we need to have in place of x of z, it is z transform of u of n, which is being shifted here. Okay, so this is z transform of x of n, and this is z to the power of minus n naught because it is being shifted by minus n naught. Fine. So can you tell me now what is going to be the z transform of this? Z transform being applied on u of n plus 2. Can you people just write it on paper? How is it going to look like? Everybody, just give it a try. Let's see how many of can get this right. If you understand one problem, you can solve many such problems because most of the things. So where people will find problem is in understanding what is x of z. What is x of z? X of z is the z transform of x of n. Okay, z to the power of minus n naught into x of z is z transform of x of n minus n. This whole together is z transform of n, x of n minus n naught. But if you take just this, it is z transform of x of n. So this is, if you apply z transform on x of n, it looks like x of z. That is what one needs to understand here. Is that okay with you, everybody? So how is it going to look like if we apply z transform of u of n plus 2? Basic signal is u of n. Okay. So shifted signal is u of n plus 2. So it looks like, see here, we are applying z transform on u of n plus 2. We are applying z transform on u of n plus 2. So it is z to the power 2. Why it is z to the power 2? Because it is plus 2 here. Here it is minus n naught, right? Because there is minus n naught here. Here is minus n naught. Since there is plus 2 here, so z, power of z would be plus 2. Into, this is z transform of x of n. So it is z transform of u of n. Everybody understand that? So don't get confused between this x of z and this x of z. No. So this is x of z of this x of n given. Okay, so don't mistake between these two. Maybe we can avoid this and just say z transform of u of n plus 2. Z transform of u of n plus 2 is z to the power 2, because x of n minus n naught, z transform of x of n minus n naught, z to the power minus n naught, because the shift is minus n naught. Here the shift is 2 plus 2, so it is plus 2 into x of z, which is z transform of x of n. So how is it going to look like? It is going to look like z transform of u of n. So You need to remember what is Z transform of U of n and its region of convergence. What is Z transform of U of n? You have to remember that. So Z transform of U of n is Z by Z minus 1. Here, Z square is as it is here. And Z transform of U of n is Z by Z minus 1 with ROC Z greater than 1. Why it is greater than 1? This is of the form A par n U of n, where A is 1. If A par n is Z by Z minus A with ROC Z greater than A. Since A is 1 here, it is Z by Z minus 1 with ROC Z greater than 1. This is something that we have seen earlier when we found out the Z transform of U of n. This is solved. So whatever results we have obtained, okay, so the same results are being used here. Understand? So ROC is a circle outside, ROC is outside the circle with radius 1 is the meaning of this. Why it is outside the circle? Because this is right-sided sequence. U of n is right-sided. Don't see U of n plus 2. Here we have written the Z transform of U of n, and the Z transform of U of n is this. Okay. Now we just multiply this and it will become Z cube divided by Z minus 1 with ROC Z greater than 1. So which ROC you would use? You would use the ROC of the what? Basic signal. Understand in this case. So basic signal is U of n. So if you substitute the same here, it would become Z cube. Nothing is happening in the denominator. So ROC would remain the same. Okay, Z square is being multiplied to the numerator here. Okay, Z minus 1 is not being affected. So the ROC would remain Z greater than 1 because this is right-sided sequence U of n. Hope everybody has understood that. I repeat, the signal given is U of n plus 2. You first need to understand which property holds good here. The property that holds good here is time shift property. And how does the time shift property looks like? Time shifted signal is x of n plus n naught. If it is x of n minus n naught, or x of n plus n naught. If it is x of n minus n naught, it is z to the power of minus n naught into z transform of x of n. If it is plus n naught, it is z to the power of plus n naught into z transform of x of n. So this is how the signal is. This is how the solution is using the property. Okay. Hope you have understood. Okay. If you solve the problem yourself, you'll understand. But yes, you need to be good with the properties and the transforms of the standard sequences. This is the standard sequence transform U of n. Okay, standard sequence is U of n, and the transform of that is z by z minus 1, and the ROC of that is z greater than 1. Let's see the next problem. X of n is equal to U of minus n. Everybody should understand this. So what operation is being performed on the basic? What is the basic signal first? Basic signal is U of n. Okay. So which operation is being performed on U of n? We are negating the time, reflection. We are taking the reflection. Okay. That is also called as time reversal. Everyone understand? So time reversal property. So which property needs to be made use here? Time reversal property, the reflection. What if x of z transform of x of n is x of z? What is z transform of x of minus n is the question. Okay, so this is what are the questions that you need to be answering yourselves. I know the z transform of x of n is x of z. What is z transform of x of minus n, which is a time reversed signal? The reflected signal is also called as time reversed signal. It is reversed in time. The positive time is converted into negative time. If there is negative time, it is converted into positive time. So it is called as time reversal. Understand the point? So how is that time reversal property looking like? Time reversal property looks like this. Simple. It's quite simple. If you have x of n in this place, if you have x of n in this place, here you will have x of z. Z transform of x of n is x of z. Z transform of x of minus n is x of 1 by z. So that means if you have just x of n, it is x of z. If you have x of minus n, z is replaced by 1 by z. That's it. So time reversal means what? In z domain, z has to be replaced by 1 by z. That's it. Simple, simplest of the properties. If you have x of n, it is x of z. If you have x of minus n, it is x of 1 by z. I hope everybody understand that. Now, using this property, how can we find the z transform of this? Okay, so where this 1 by z is being substituted, this 1 by z is being substituted in the z transform of x of n. That needs to be understood here. So here, we also should know the z transform of u of n. Okay, see here. So z, since this is there, z transform of u of minus n is, this is z transform of u of n, okay, where z is being substituted by 1 by z. See, this is z transform of x of n, where z is being substituted as 1 by z. So this is z transform of u of n, basic signal, okay, where the z is being substituted as 1 by z. And here see the ROC here. ROC is z greater than 1, right? So in place of z, we need to have 1 by z. So in place of z, see, in place of z, we have to have 1 by z. That means here in ROC also we have a z. So that z also needs to be substituted by 1 by z. So 1 by z greater than 1 is as good as saying z less than 1. Understand? How did it get z less than 1? See, this is for positive time sequence, u of n. This is for negative time sequence, which is u of minus n. Okay, so if you substitute z as 1 by z, it is going to look like 1 by z, 1 by z minus 1. Okay, so that would become 1 by 1 minus z with ROC z less than 1. Okay, so you need to understand that in z transform, x of z has to be replaced as x of 1 by z. That means what is x of z? X of z is z transform of x of n. So we have z transform of u of n. There, since it is u of minus n, the z is being replaced as 1 by z. Okay, so because of this, we are getting this result 1 by 1 minus z. And how the ROC needs to be found out? Okay, ROC of u of n is z greater than 1. ROC of minus u of minus n is 1 by z greater than 1. 1 by z greater than 1 is as good as saying z less than 1. If you take this z here, it is 1 greater than magnitude z, 1 greater than magnitude z, or you can say z magnitude z is less than 1 and the same. Hope you have understood. In the previous problem, we used time shift property. Here we are using time reversal property. Both the problems are done using the u of n as the basic signal. Let's take the next one. N u of n. We have solved this problem. Ramp sequence, unit ramp sequence. We have solved this problem by using the formula x of z is equal to summation ranging from 0 to infinity x of n into z to the power minus n. So using that formula, we have found out the z transform of this. But the purpose is different now. Purpose is to find out the z transform of this by using the property. So which property would be applicable here? It needs to be understood. Which property is applicable here needs to be understood. Okay, we shall see which property can be useful here. Using time differentiation in the z domain. Using differentiation in z domain property. So how does this property looks like? It's very similar to the properties that we have seen in Laplace transform in network analysis. Okay, the same properties are being applied in z domain. So this property, the property that needs to be used here is differentiation in Z domain. So how does that look like? Yeah, this is the property. See, there is nu of n, right? There is nu of n. Fine. So we have what if, well, we know what to do when u of n is there, but we don't know what to do when nu of n is there. So which property is applicable? See, n x of n. If we have x of n, it is x of z. If we have n x of n, it is minus z into the differentiation of x of z with respect to z. Differentiation of x of z with respect to z. What is this x of z? X of z is the z transform of x of n. So why is this property called as differentiation in z domain? This property is called as differentiation in the z domain because on this is time domain, this is z domain. In z domain, it is being differentiated with respect to z. The x of z is being differentiated with respect to z. That is why it is called as differentiation in z domain. So when would there be a differentiation in z domain? When the signal is multiplied by n. Any signal multiplied by n would have this differentiation in z domain along with minus z, mind you. If you have u of n plus 1 or n plus n naught, time shift. If you have u of minus n, it is time reversal. If you have n u of n, it is differentiation in z domain. Okay, so any signal, if it is multiplied by n, then you need to use this property, remember. Okay, so very first thing that you need to understand is what is x of z. X of z is z transform of x of n, mind you. So in this place, what you need to have, suppose we are considering this, in this place what you need to have, you need to have the z transform of u of n. Okay, so how to represent that is like this. Since for nx of n it is this, for nu of n it is minus z d by z dz of z transform of u of n. This is z transform of x of n, so I'll have z transform of u of n. Everybody's okay with that? Fine. What is z transform of u of n? Now needs to be understood. What is z transform of u of n? Z transform of u of n is z by z minus 1 with ROC z greater than 1. Okay, so this needs to be substituted in this place. Substitute that in this place and then differentiate. Fine. Let the ROC be same. Let's not bother about it. Just substitute z by z minus 1 in this place and differentiate that with respect to z, and that looks like this. Okay. Now, if you differentiate z by z minus 1, what is that you're going to get? Can you differentiate it, everybody? Do it. Let's see. Differentiate z by z minus 1 with respect to z and multiply minus z to that. What results you get? Let's see. Do that, everybody. What property it is called as when we are differentiating? Done? Okay, let's wait for some more time. You're differentiating z by z minus 1. So those who are solving it are focusing, are putting efforts. Those who are not should be doing this, because let's be positive about what we are doing. Okay, then certainly things will happen in our favor. So we want to learn, we are learning. Okay, let's not bother when we meet in the college, after meeting, how far we are going to cover this again. Okay, so they're all just question marks as of now, because the lockdown is going to be extended again. Better it is extended because the numbers are raising. What is expected at most from us? To be at home. We're not wasting time being at home. We are learning also. Maybe not very effective, but s we are doing something. Okay, so let's be positive about that. So I want everybody to differentiate z by z minus 1. Be positive about what you're doing. Okay, if you have to see the negatives, everything has negatives. Okay, if you concentrate on them, you cannot do anything. You can just start giving excuses. So without giving excuses, what best we can do with available resources is what is important in these critical times. Fine. So how does the Z transform, the differentiation of Z by Z minus 1 with respect to Z would look like? See, here it would look like the whole, if you take minus Z, you leave. Okay, the Z transform of that would be minus 1 by Z minus 1 whole square. So ultimately it would become this after multiplying minus Z. I hope I'm correct here. Okay. Therefore, the Z transform of n u of n is Z by Z minus 1 whole square. Okay. With the ROC, this. This is what is the ROC that we need to be using for this also. Because this is right-sided sequence. Okay. And we have u of n. So the ROC of u of n would be holding good here. Fine. So we have seen three problems here. I've not changed. I've continuously taken the problem numbers. Okay, starting from the beginning. This is the 10th problem for which we are finding out the Z transform. Okay, so this is continuous numbering, but using the properties, we have solved three problems. Problem number 8, 9, 10. In 8th problem, using the properties, it was time shift property. In 9th problem, it was time reversal property. In this, it is differentiation in Z domain. When do you use differentiation in Z domain? When we multiply a signal by n. Okay, just to see how much you understand, can we have a signal with t as the multiplication factor here? In place of n, can we have t? Can we have t u of t as a signal? Can we have Z transform of t into u of t is the question. Z transform of t u of t. No is the answer. Why we cannot take Z transform of t u of t? Because we need to look at only we need to look at only the discrete time signals, not the continuous time signals. Everybody understand that? We need to take discrete time signals, not the continuous time signal. So in that sense, tu of t is not possible. It should be nu of n only. Fine. There are some questions we need to be prepared for. Yeah, this is the assignment question that we have. So which properties needs to be used for this? Let's have that discussion now. Okay. So these are the problems for assignment. Fine. Which properties need to be used for this? Okay. Which is the basic signal in this? Is u of n the basic signal? Or a par n u of n is the basic signal? Or the whole signal given is basic signal? Needs to be understood. Yes, u of n is basic signal, but since there is a of n, you can take this whole signal a par n u of n as the basic signal, because we know what is the Z transform of a par n u of n. What is Z transform of a par n u of n? It is Z by Z minus a, the positive time exponential. So the positive time exponential being multiplied by n. The positive time exponential is being multiplied by n. Understand that? Okay. So which property you use? Since a signal is being multiplied by n, you will use differentiation in Z domain property. Here also you have a par in u of n, but there is an extra signal, that is there is an extra scalar a par minus 1. So that a par minus 1 can be separated and kept somewhere aside. So it would still be the same signal, a power n u of n being multiplied by n. So deal with these two signals using the properties. Okay, do this assignment in assignment book. Fine, we will get back. We'll get back again with more problems. Okay, so we have another problem left out. Let me take that using the properties. Yeah, that is Z transform of a power n u of n. Okay, now let's see a power n cos omega naught n u of n. So sinusoidal signal is there. Okay, so how can we find out the Z transform of this using the properties is the question. So let's find out the Z transform of this using the properties. So before finding out the Z transform, we should be able to understand the Z transform of cos omega naught u of n. So this we have found out. The Z transform of cos omega naught n u of n is found out. Okay, so which is this was given for the assignment. Maybe I don't know how many of you solved that. If you solve that, it's easy. You can solve it. This is how it is going to look like. The Z transform of cos omega naught n u of n. Okay, now to that signal we are multiplying a power n. So which property is this? Multiplication by an exponential. This is an exponential, right? So cos omega naught n u of n is being multiplied by an exponential. So if you multiply this signal by an exponential, what is going to happen? This is the another property that we're using. Which property is that? By multiplication by an exponential. That property looks like this. So if x of n, which is x of n, cos omega naught n u of n is x of n here. So that x of n is being multiplied by an exponential. A power n in discrete time is exponential. It's not e power at. A power n itself is an exponential in discrete time, mind you. Okay. So x of z, if you have x of z in z domain, that z has to be replaced by z by a because you have an exponential a power n. If you have exponential, if you have x of z is the Z transform of x of n. X of z is Z transform of x of n. Then x of z by a is the Z transform of a power n x of n. That means in place of z, you need to have z by a. When you would have in z by a in place of z, you will have z by a in place of z when there is an exponential a power n. That means here, now if you bring a power n here, in place of z, you will be z by a. Okay, this ROC is found out to be z greater than 1. Okay, so see here, ROC is z greater than 1 here, right? In place of z also, we need to bring z by a greater than 1. Okay, which means that z is greater than a. See here, that is what is done. Wherever z was there, okay, since a power n is there along with this, that z is being replaced by z by a. And if you work out, yeah, I think it's time for the next class. Yeah, I think you can give your attendance. We'll see it in the next class. Everybody start giving your attendance. It will be time for your next class. Yeah, you can give the attendance and you can leave. We will take this problem again in the next class. Okay, so everybody give your attendance in chat. We shall take the same problem in the next class. Okay. Your attendance, your you were 42. No problem. You just give your attendance and leave the class. Everybody given? Yeah, we have 3 moments. No, not a problem. It will be late for you for your next class. Give your attendance and leave. We will meet again in the next class tomorrow. Okay, fine. Till then, take care and we'll meet again. Fine.